Assalamu alaikum students. Today we are doing A levels AS chemistry P2 variant 1 October November 2023. So let's look at the first question. The elements phosphorus, sulfur and chlorine are in period 3 of the periodic table. Table 1.1 shows some properties of the elements P2Cl. The first ionization energy of S is not shown. Number of electrons in 3p subshell, total number of unpaired electrons, first ionization energy. These are the things that are written. Okay. So property P, number of electrons in 3p subshell. For that, we need to know the electronic configuration of all three of them. All right. So phosphorus, if you remember phosphorus, if you do not, the periodic table is given to you. Okay. Phosphorus, I believe, has 15 electrons, if I'm not wrong. Let's just confirm. How many electrons phosphorus has? Yes, it will have 15 electrons because its atomic number is 15. Sulfur will have 16 and chlorine will have 17. All right, so they will have just one more electron from the previous one. So let's make the electronic configuration of phosphorus first. Okay, long paper, I suppose. All right, so B, uh, its electronic configuration will be 1s2, 2s2, 2p6, 3s2. So these are 2, 2, 4, 10, 12. So now 3 remaining. So it will be 3p3. All right. That will be the electronic configuration of phosphorus. Now, if we talk about the electronic configuration of sulfur and chlorine, we will see that because they have just one more electron in each one. So instead of 3, uh, chlorine will have 4, 3p4, and sulfur will have 3p4, and chlorine should have 3p5. All right. So in the 3p subshell, this guy has 3 electrons, this guy has 4 electrons, and this guy has 5 electrons. All right. Total number of unpaired electrons. How many unpaired electrons will it have? Okay. So for that, we are going to only draw the last subshell, the 3p subshell, because all other shells are complete, meaning they have paired electrons. All right. The 3p subshell, and we can duplicate it like this. Okay. All right. The 3p subshell is the 3p subshell. All right. We can duplicate it for this guy, and we can also duplicate it for this guy. All right. This guy can be purple though. I have a little bit change. So 3p will have 1, 2, 3 electron because it has 3 electrons, right? Because it has 5 electrons, it will be 1, 2, 3, 4, 5. All right. And this guy is going to have 4 electrons. 3p4, 1, 2, 3, 4. So how many unpaired electrons are there? 3. How many unpaired electrons are here? 2. And how many unpaired electrons are here? 1. All right. So the answer will be 3, 2, 1. Next question. Complete table 1.1 to show the number of electrons. We've done that. Construct an equation to represent the first ionization energy of P. So first ionization of energy of P means P is in its gaseous atomic state and it loses one electron to become gaseous P ion. All right, gaseous P ion and then E minus. This is the first ionization energy of literally anything. All right, all you have to do is write the symbol of that thing, write it in its gaseous state, give it +1 charge in the product, have it in its gaseous state, and have one electron loss, right? Three possible values for the first ionization energy of S are given: 1000, 1160, and 1320. And they are asking circle the correct value, explain your choice by comparing your chosen value to those of P and Cl. All right. So they haven't given us the value over here. All right. So yeah. So now how are you going to say कि what should be its values? ठीक है. So which one will you choose? All right. Will you choose 1000, which is less than both this and this? 1000 kilojoule ionization energy should be required. Will you choose 1160, it is more than P, but it is less than S, or will you choose 13, 20, it is more than Cl or and less than P? For that, you have to remember the trend. You have to remember the trend, all right? And the trend in ionization energy was explained to you in the first chapter. And let me take you to that chapter again. It was explained to you according to period 2, but this is period 3. Period 3 trend is also explained. It is explained in the later chapters, but I remember that there was a trend over here that we can uh, focus on. Let's try and look for it. Right here, okay. Now in this trend in ionization energy, you should see that this is group 1, this is group 2, this is group 3, this is group 4, this is group 5, or we can say this is 13, 14, 15, this is group 16, this is group 17, and then this is group 18, all right. Always see the trend is always the same. Group 15 has more ionization energy than 16, but less ionization energy than 17. Meaning group 16 has lesser ionization energy than both N and F. Now, if we compare phosphorus, sulfur, and chlorine, phosphorus is in group 15, sulfur is in 16, and chlorine is in group 17, right? Sulfur should have lower ionization energy than phosphorus and chlorine both, and then this should be the ionization energy pattern. So if the ionization energy of phosphorus was given as 1060 and chlorine was given as like 1280, I think, I don't remember exactly, sulfur should be less, meaning the out of the three values only 1000 is the lesser value than phosphorus and chlorine both, right? So therefore the ionization energy of that question should be, the answer should be 1000, right? We should circle 1000, all right. And over here we have to give the reason why as well. Okay, okay. So 4 mark question, we have to explain circle is, let's suppose circle is 1 mark, all right. Now we are going to explain why. So this should be 1000. Why should it be 1000? First off, you should understand that the ionization energy of sulfur is less than chlorine because chlorine has greater positive charge, yeah, greater nuclear charge. Okay, ionization energy of S is less than Cl as Cl has a smaller atomic radius and a greater electrical charge. Not electrical charge, greater nuclear charge. Full stop. All right. And then why should sulfur have greater why should sulfur have lesser ionization energy than P even? Why should P have more ionization energy and S have less ionization energy? Why does the trend not change? Matlab, generally we say across a period ionization energy increases, but phosphorus has more ionization energy and sulfur has less ionization energy. Why is that? Because if you observe that phosphorus have a half-filled P subshell, which is a more stable configuration than a not half-filled P subshell. Okay? So it is not half-filled P subshell, it has one extra electron. Once this electron is lost, it will be more stable actually. A half-filled subshell and is stable. A completely full subshell is absolutely stable, but a half-filled subshell is also relatively stable. So this is more stable than this. All right, that is why. So we are going to explain that to it. All right. So we will say that we will say that on the other hand, and not hang. On the other hand, S has lesser ionization energy than P, as P has one electron each in each, one electron each in the three orbitals of p subshell. Sulfur has two electrons in one of the orbitals, which produce repulsive forces and make it easy for one of the electrons to be lost, for one of the electrons to be lost. Full stop. All right. Next question. P3 minus, S2 minus, and Cl minus have the same number of electrons. Give the full electronic configuration of P3 minus, which means it has 15 plus 3, 18 electrons. All right. So it will be 1s2, 2s2, 3s2, sorry, 1s2, 2s2, 2p6, 3s2, 3p6. All right, because it has three complete shells. This is 18 electrons. All right. State the trend in ionic radius shown by p3 minus, s2 minus, and cl2 minus. We say that whenever electrons are gained, the ionic radius increases. Whenever electrons are gained, ionic radius increases, meaning anions have a larger ionic radius the more number of electrons they gain. All right. So that means this guy has gained three electrons. So it should have the largest ionic radius. This should have a lesser, smaller ionic radius, and this should have the smallest ionic radius amongst the three. Okay. So we will say that ionic radius increases as the anionic charge increases. All right. Full stop. So yeah, this means that P3 minus has largest radius while Cl minus has the smallest. Full stop. Okay, this is because, and why does this happen? Why does gaining electrons uh causes an increase in the atomic radius or increase in the ionic radius? Two reasons. Already chloride has 17 protons, phosphorus has 15 protons. So it has less positive charge to pull those electrons inwards. It has more positive charge to pull those electrons inwards. All right. Secondly, Secondly, there is going to be, because the gain of electron is done, and it is done in such a way that electrons are gained in the same shells, right? This also has three shells, this also has three shells, this also has three shells. They will experience the same amount of shielding effect. All right. So you can answer this in two methods. All right. So you will say this is because Cl has greater nuclear charge than P, while their shielding effect, shielding, shielding effect is relatively similar. While the shielding effect is relatively similar. Next question. A student does three tests on separate samples of NaCl. Complete table 1.2 with the observations the student makes in each test. Test addition of few drops of Br2. Okay. NaCl. They are doing it with NaCl. If you add bromine in NaCl, will there be any reaction? Will there be any reaction? The question is about the halogen displacement. Will bromine displace chlorine? The answer is no. Why will bromine not displace chlorine? Because chlorine is more reactive than bromine. So we will say no change. No change. All right. Okay. Now next, addition of few drops of H2SO4. Well, if even few drops of H2SO4 are reacted, right, and the reaction even takes place, NaCl plus H2SO4, let's suppose it produces Na2SO4 plus HCl, equation balance by 2, all right. Even if this reaction takes place, what would be the observation? There was an acid before, there is an acid still. There was a salt before, which was colorless, by the way. You group 1 elements, they are colorless. And sodium sulfate will once again remain colorless. So should there be a change? There should once again be no change, right? Okay. The next, addition of few drops of AgNO3. Now that is different. NaCl plus AgNO3. All right. If a displacement reaction takes place, it forms NaNO3 and it forms AgCl. All right. Now these are two salts. This is aqueous. This will stay dissolved in water and it will be colorless. Similarly, AgNO3 is also colorless. Right. NaNO3 that is produced is also colorless. But this is an insoluble salt which is a white solid. So what will we observe? We will observe that white precipitate is formed. All right, white precipitate is formed. Next question. POCl3 shows similar chemical properties to PCl5. All right, we can just leave that here by the way. Okay. POCl3 shows similar chemical properties to PCl5. All right. POCl3 has a melting point of 1 degree Celsius and a boiling point of 106 degrees Celsius. POCl3 reacts vigorously with water, forming misty fumes and an acidic solution. Explain how the information in D suggests that structure and bonding of POCl3 is simple covalent. How do we know that its structure and bonding is of simple covalent bonding, right? How can we know? How can we know? Two reasons. It has given us two things. One is this, right? And then one could be this. We could consider that, or the chemical property itself, right? Why do we want to say it has similar chemical properties when we know the chemical properties? What are these two things telling us? One, POCl3 has low melting and boiling point. POCl3 has low melting and boiling point, which means it has weak intermolecular forces of attraction, full stop. And the second thing is it reacts like a simple molecular compound in water. All the simple molecular compounds in water, they were reacting with water and they produce an acid and they produce hydrogen chloride gas, right? They produce an acid and they produce hydrogen chloride gas, right? How? By reacting with H2O. Anything that reacts with H2O, the reaction is called hydrolysis reaction, right? Okay. So those guys, they were doing hydrolysis reactions, and this is a property of simple molecular compounds, right? Okay. So we will say that secondly, it reacts vigorously due to hydrolysis forming misty fumes of hydrogen chloride. Stop. All right, construct the equation of PuCl3 with water. So we just do H2O, and it's going to produce, because it is P, phosphoric acid. So phosphoric acid has the formula H3PO4, and along with that, it produces HCl. All right, to balance the equation, we need at least a 3 over here. All right, and we need at least a 3 over here to make 6 hydrogens and 6 hydrogens, 4 oxygens, 3 ones are 3 plus 1, 4 oxygens. All right, everything is balanced. Next, POCl3 contains a double covalent bond between P and O. All right, so POCl3, P and O has a double covalent bond, and then it must have single covalent bonds with the 3Cl. All right, that means it is sharing 2 electrons with oxygen, 1 electron each with each chlorine, right? Like that. And now we want to have the other electrons of all the guys. So let's assume that the dots were phosphorus. So let's make crosses for these guys, all right? So cross, 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 cross. Because chlorine shares 1 electron and has 3 pairs. That is how group 17 guys are. Oops, that is not chlorine, so that would be wrong. Oxygen, because it has 6 total electrons, it has shared 2, so it should now have 2 more electrons. It should now have 2 more pairs of electrons, all right, like that. Next question. POCl3 forms when PCl3 reacts with O2. PCl3 plus O2 gives POCl3. Table 1.3 gives some relevant data. All right, process enthalpy change of formation of PCl3 minus 289, enthalpy change of formation of POCl3 minus 592, O2 to 2O gas is 496. Define the term enthalpy change of formation. So we want to define what is enthalpy change of formation. So it is, what is it? It is basically the amount of matlab the moles, yeah, amount of energy released or absorbed when 1 mole of product is formed from its elements. All right, so we are going to define it like that: amount of energy absorbed or released when 1 mole of product is formed from its reactants. All right, now the question is, calculate the bond energy of P double bond O in POCl3 using table 1.3. Show your working. We want to calculate out the bond energy of P double bond O. We want to calculate out the bond energy of P double bond O. All right. So for that, we want to understand a few things. The enthalpy change of formation of PCl3 is minus 289, meaning the phosphorus joining 3 chlorines, that is minus 289. So POCl3, that is minus 592. All right. And the thing is, to make a minus 592 or to get 1 oxygen, we need an O2 and we need to break it into 2O, right? All right. So this is how we are going to have to write it down. P, Cl, Cl, Cl plus O double bond. Yeah, this is the reaction. O double bond O gives 2 times P, Cl, Cl, Cl double bond O. All right. So basically, this is also 2 times. All right. So each time this forms or breaks, the energy released is minus 289. The energy released is minus 289. All right. And each time this breaks, as we can see over here, the energy released is plus 496. All right. And each time this whole compound forms, the energy released is minus 592. Minus 592. Now, if I were to write the whole thing, do we know the delta H? I don't suppose we know the delta H. Yeah, we do not know the delta H. But the formula is very simple. But I'm going to put delta H in it otherwise. Um, okay, so this will become 2 times each time it forms, that is minus 289, all right, plus 1 oxygen, that is plus, do we write plus or do we write minus? I think we are going to have to write minus 496 over here. I think we are going to have to write minus 496 over here. All right. Because O2 to 2O is plus 496. Oh, but we need bond breaking. So I think we need plus 496. So plus 496. Right. Arrow 2 times. So this much can be called minus 289. Right. Plus, or I could just say plus P double bond O. This is the whole thing on this side, right? This is the whole thing on this side. I hope this makes sense. All right. Acha. And to say this whole thing, whenever it forms, it produces minus 592 kilojoule per mole of energy. All right. So we can say that this whole thing is equals to minus 592 kilojoules of energy times 2 because it is forming twice, right? So it will become minus 592 times 2 is equals to 2 times PCl3 and 2 times P double bond O, right? This should be the way to move forward. All right. So what is 2 times? Where is my calculator? It's right here. What is 2 times 592 equals to 1184 minus is equals to 2 times PCl3. What is 2 times minus 289? This will be 578 minus plus 2 times P double bond O. So this will go on the other side, minus 1184 plus 578 is equals to 2 times P double bond O. So minus 1184 plus 578, this will be equals to minus 606. This is 2 times P double bond O, and the P double bond O be equal to minus 606 divided by 2. That should be equal to, divided by 2 should be equal to minus 303. Minus 303. All right. So minus we do not write bond energy. When we are writing the bond energy, we'll just write plus 3, just 303, not minus. All right. So this will be the way to go. All right. On to the next question. Barium hydroxide BaOH whole twice is a strong base used in inorganic and organic reactions. G. Answer. 1 second. अच्छा जी तो we got the wrong answer for this question और Haris has explained कि इसमें 551 answer आएगा according to the marking scheme and it is still unclear to me. uh, something is not working out in my head तो उसको इंशाल्लाह हम लोग बाद में देख लेंगे but for now according to the marking scheme we had to do enthalpy change of formation of PoCl3 should be equal to enthalpy change of formation of PCl3 plus conversion of oxygen O2 to two oxygen atoms, that is atomization of oxygen, minus the bond enthalpy of P double bond O. That should be the equation, and then once you solve it, you are getting 551. That is the answer according to the marking scheme. But I will look deeper into it as to how or why the equation was made in such a way. Okay? So let's move on to the next question for now. Barium hydroxide BaOH whole twice is a strong base used in inorganic and organic reactions. Figure 2.1 shows a reaction scheme involving BaOH whole twice. All right, so the question is BaO. When it undergoes reaction 1, it produces barium hydroxide when it is reacted with H2O. All right, and in reaction 2, it produces barium carbonate and H2O. All right. So first barium oxide is mixed in water to produce barium hydroxide. This is the reaction of barium oxide with water. All right. And barium hydroxide, when it reacts with ethanoic acid, it is going to produce another thing and water. State the variation in solubilities of group 2 hydroxides. What happens to solubility of group 2 hydroxides is what they are asking. So we know that solubilities of hydroxides increase down the group. Okay? They increase down the group. All right, solubility of hydroxides increase down the group. State what is observed in reaction 1. What do we observe in reaction 1? All right, so this is solid and this is aqueous. So we are going to say a white solid disappears. All right, because barium oxide is a group 2 oxide and group 2 oxides are white. Group 1 ionic compounds are also white. So we say that white solid disappears. Suggest a reactant for reaction 2. So for reaction 2, we want to suggest a reaction. How can we make a hydroxide into a carbonate? How does a hydroxide become a carbonate? For that, I mean, a little bit of O levels knowledge is also required. You remember lime water, CaOH whole twice, right? Lime water. How did it used to become calcium carbonate, CaCO3? How would you convert lime water into calcium carbonate? A very famous reaction was lime water turns milky. What would lime water react with to turn milky? With carbon dioxide, right? So the similar reaction should take place over here, meaning if you have barium hydroxide and you want to make barium carbonate, you are going to require carbon dioxide again. All right, so you want to use CO2, which is carbon dioxide. All right, so to make a carbonate from a hydroxide you require carbon dioxide. All right, next identify A. So A would be the salt of barium reacting with ethanoic acid and it should be barium ethanoate. All right, so we want to identify it, so we can just write barium ethanoate. If you want to write the formula of barium ethanoate should be CH3COO whole twice Ba. All right, why? Because ethanoate ion is CH3COO minus and barium is Ba plus 2, right? So 2 goes here and 1 comes here. So CH3 double O whole twice, Ba, and the name is Ba, barium ethanoate. Next, barium hydroxide is made by reaction of Ba with water. Write an equation for this reaction. If barium reacts with water, we know it will react very vigorously because reactivity of group 2 increases down the group. It should produce barium hydroxide, and along with that, it should also produce hydrogen gas. All right. Next question. The mineral, the mineral barytocalcite. All right, the mineral barytocalcite contains both BaCO3 and CaCO3. Both compounds decompose on heating. State which the compound decomposes first when barytocalcite is heated. All right, so we know that the decomposition is based on the bond strength. The stronger a bond is, the greater its chance of withholding that, right? The stronger a bond is, the greater will be its chance of holding on to themselves when heating, right? So, for example, barium and calcium, when we compare their reactivities, calcium is less reactive, barium is more reactive, right? If calcium is less reactive, it means when it forms calcium carbonate, this bond should be weaker. When barium carbonate forms, this bond should be stronger. That is how we know, okay, which one's more reactive. The more reactive elements form stronger bonds, all right? Okay, with compounds. So that means that in this scenario, calcium carbonate should get thermally decomposed first, right? Calcium carbonate should get thermally decomposed as it has stronger, it has a weaker ionic bond than BaCO3. All right. Next question. Construct an equation for the complete thermal decomposition of barytocalcite. The formula of barytocalcite is BaCa CO3 whole twice, BaCa CO3 whole twice. When it is heated, when we heat it, it should produce barium oxide, because let's just treat it like barium carbonate and calcium carbonate, right? When they are heated, they will produce barium oxide, they will produce calcium oxide, and they will produce 2 moles of carbon dioxide. Why? Because 1 mole of carbon dioxide from this carbonate and 1 mole of carbon dioxide from this carbonate. All right. Next question. Barium hydroxide is used to hydrolyze organic compounds. Figure 2.2 shows the reaction of B with BaOH whole twice, followed by acidification. All right, this probably would be some kind of ester or something. Draw the structure of the organic products of the process shown in figure 2.2. All right, so not an ester. Oh, it is an ester, COOCH3. All right. When we do barium hydroxide, when we do a strong alkali and then followed by an acid, what would happen? What would happen? So the hydrolysis happens, right? Hydrolysis takes place. Basically, what happens is this ester will be broken down, and this nitrile will also be broken down, and they will produce what they will. This will produce carboxylic acid and alcohol, right? This will produce carboxylic acid and alcohol, and it will also produce. This will also produce carboxylic acid, and along with that, it produces an ammonium salt, right? So organic product 1 and organic product 2, that is what we have to write down, right? So the first organic product should be, once when we have to see this one, right? We have to see this box to know the 2 organic products that will form, right? This is C double bond O CH3. All right, because of the addition of barium, this bond will break because of hydrolysis, right? H and OH, right? This bond also breaks. This H goes joins with O. This OH goes joins with carbon, right? Okay, so one तो methanol हो गया आपका, CH3 OH हो गया, all right? Or if you want to write it flipped, you can write OH HO CH3. It's okay. ठीक है, सही है. So that would be your methanol, the first organic product. The second organic product should be the whole skeletal structure. That, and duplicate this line like this. All right, duplicate this line as well. The nitrile also becomes carboxylic acid, and esters also become carboxylic acid by strong alkali followed by acidification. All right. There should also have been an ammonium salt that produces, because when a nitrile converts, it produces an ammonium salt usually. All right. Next question. Potassium chlorate KClO3 is widely used as an oxidizing agent to make O2. All right. KClO3, it helps produce oxygen. All right. Define oxidizing agent. What is an oxidizing agent? A substance which oxidizes another substance while getting reduced during the process. While getting reduced during the process. Full stop. Next question. KClO3 decomposes when heated. MnO2 catalyzes the exothermic decomposition reaction. Complete and label the diagram in figure 3.1 to show the effect of MnO2 on decomposition of KClO3. All right. So we say KClO3 decomposes when heated. So that should be your first graph, right? Oops. Right. This should be your first graph. Okay. Now, if we use a catalyst, then this graph should not have such high activation energy, right? This graph should not have such high activation energy if we are using a catalyst. This, so that. Right. Now I'll duplicate it and decrease it. All right. So this graph, this is reaction with MnO2 as catalyst. All right. And this is going to be the reaction without MnO2 as catalyst, right? So two reactions like that. All right. Next, when KClO3 is heated without a catalyst, KClO4 and KCl form. So 4 KClO3 gives 3 KClO4 plus KCl. Explain why this reaction is described as a disproportionation reaction. All right. Why would this reaction be described as a disproportionation reaction? I mean, the straightforward answer is the same species getting oxidized and reduced, but you can try and calculate out the oxidation states. So right now 4 KClO3. So 4K means K means plus 1 and Cl over here is plus 5 right now. Okay, because oxides are a total of minus 6. Over here K is plus 1, Cl is going to have to be plus 7 because oxides are minus 8, 4 oxides, and then over here K is plus 1 and Cl is minus 1. So it is getting reduced and it is getting oxidized. So both things are happening. All right, it is getting reduced and oxidized simultaneously. All right, so we say because same species gets oxidized and reduced. Full stop. Next question. Molten KClO3. Molten. This is not working. One second. Molten KClO3 reacts with glucose C6H12O6. 4 KClO3 gives C6H12O6 gives 6CO2 plus 6H2O plus 4 KCl. KClO3 melts at 630 Kelvin. At this temperature, Both CO2 and H2O are gases. Use the ideal gas equation to calculate the volume in meter cube of 1 mole at 630 Kelvin and 1.0 into 10 to the power 5 pascals. All right, so use the ideal gas equation to calculate the volume in meter cube of 1 mole of gas, 1 mole of any gas, right? So all we have to do is use the formula PV is equals to nRT. All right. They did not, I mean, yeah, well, so moles is equals to 1, pressure is equals to 1 into 10 to the power 5. All right, and temperature is equals to 630, and value of R is 8.31. All right, so we want to calculate out V is equals to 1 multiplied by R 8.31 multiplied by uh, temperature 630 divided by pressure 1 into 10 to the power 5. All right, so we are going to do 1 times 8.31 multiplied by 630 to divided by 0.523. All right, so the answer is 0.523 meter cube. All right, 0.523 meter cubes. All right, I hope that makes sense. Next, 5 grams of C6H12O6 reacts completely with molten KClO3. Use your answer to D. Part 1, to calculate the total volume of gas released at 630 kelvins and 1 into 10 to the power 5 pascals in this reaction. If you were unable to answer D part 1, use 0.0463 meter cube in this equation. This is not the correct answer, D part 1. All right. So the answer to it was 0.0523. Acha, I have written 0.523. 0.0523. All right. This is also 0.0523. All right. We have been told that 5 grams of C6H12O6 is produced. All right. Okay. So both CO2 and H2O are gases. So a total of 12 moles of gases are produced. A total of 12 moles of gases is produced. All right. How many moles of glucose? 5 grams. All right. So first we have to find out the moles of C6H12O6. So yeah, moles of C6H12O6. This is the first thing you want to calculate out. All right. That is how you're going to have to move. Okay. So mole equals to mass upon mr. All right, mass is said to be 5. C6H12O6 would be 12 times 6 plus 12 times 1 plus um 6 times 16. All right, so when we put it all, 12 times 6 times 6 plus 12 times 1 plus 6 times 16 equals to 180. So this will be 5 upon 180. 5 divided by 180. The answer is 0.027. All right. The answer is 0.0277. So 0.027777, meaning 0.20278 moles. All right. So moles of gas produced. Moles of gas produced. For that, we want to know, okay, how many moles? 1 ratio 12. All right. So the ratio is 1 ratio 12. All right. So we say 1 mole C6H12O6 produces 12 mole gas, right? So 0.0278 is equals to X. So X is equals to 12 times 0.0278. So moles of gas produced, we just multiply this value by 12. The answer is 0.0333. All right, so X is equal to 0.333 moles of gas are produced. All right, so now volume of gas. All right, we know that 1 mole gas has a volume of 0.0523, right? So 1 mole equals to 0.0523. 0.333 moles equals to X. So X is equals to, once again, we just have to multiply by 0.523 equals to, the answer is 0.174. All right, 0.174. 0.174 mole meter cube. All right, this should be your answer. Next question. The structure of glucose C6H12O6 is shown in figure 3.2. Okay. Complete table 3.1 to identify the number of primary, secondary, and tertiary alcohols in alcohol groups present in structure shown in figure 3.2. All right. So we want to tell how many primary, secondary, and tertiary alcohols are present. All right. So for that, we want to make carbons and we want to show, okay, this guy is joined to two hydrogens. All right. This guy is joined to one hydrogen. This guy is joined to one hydrogen. All right. This guy is joined to one hydrogen. And this guy is joined to one hydrogen as well, and then there's a carbon. All right, so we can obviously see that there are a total of 1, 2, 3, 4, 5 hydroxy, right? There are a total of 5 hydroxy groups, OH groups, right? Out of them, this guy is primary because it is only joined to one carbon, right? The number of primary is only one. All right, this guy is secondary because it's joined to one OH and two carbons and only one hydrogen. This guy is also secondary. This guy is also secondary, and this guy is also going to be secondary. So we have 1, 2, 3, 4 secondary alcohols. So that means we should have zero tertiary alcohols because there are total of 5 hydroxy. Yeah, so we have zero. All right, next, separate samples of aqueous glucose are tested with reagents shown in table 3.2. Complete table 3.2 with the observation for each reaction. Write no reaction if applicable. All right, so will there be a reaction or not? We will have to see. Okay, so the first we are going to observe, the first thing we are going to observe is um, acidified KMnO4 and warm. Will anything happen if we add KMnO4? KMnO4 is an oxidizing agent. Will there be any changes in color? Bilkul. Everything gets oxidized, right? Even this is an aldehyde at the end. If you see, this is an aldehyde at the end, all right? So we will say that color changes from purple to colorless, okay? So color changes from purple to colorless. All right. Next, Felling's reagent and warm. Well, Felling produces a positive result whenever there is an aldehyde present, right? Whenever there is an aldehyde present, and Felling goes from copper 2 oxide to copper 1 oxide, Cu plus 2 to Cu plus 1, right? Cu plus 2 is blue. Later on, Cu1 plus forms, and that color is red, orange, right? So, because of the presence of the aldehyde group, the Felling test will change its color, right? We will say color change from blue to blue to orange. All right, next question. Alkaline I2 and warm. Now alkaline I2 is usually for ketones, or it is also for ethanol, meaning aldehyde. Only the only aldehyde is the aldehyde in which it is only for things that have a C double bond or CH3. All right, that is what the alkaline I2 is for. All right, over here we are going to know, we observe that there is no CH3 to this aldehyde. All right, in fact there is no CH3 anywhere. So it just absolutely confirms that there cannot be any yellow precipitate over here. All right, meaning this will not give a positive test, meaning observation with glucose there will be no change. There will be no change. All right, next question. There are many structural isomers of C6H12O6. Many structural isomers of C6H12O6. Define structural isomer. What is a structural isomer? Structural isomer, if we define it, is those chemical compounds which have same molecular formula but different structures, right? Chemical organic compounds with same molecular formula but different structures. All right. Question number 4. Compounds C and D are alkenes with the same molecular formula C5H10. Give the systemic name of D. So what would be the name of D? If you look at D, this is the first carbon, this is the second carbon, third carbon, and fourth carbon. On the third carbon, there is a methyl branch, so its name will be 3-methyl bute because the longest chain is 4 carbon long, 2 in 3-methyl butene. Explain why C and D do not show geometrical cis-trans isomerism. Why does C and D do not show cis-trans isomerism? Because the carbon-carbon double bond in C, it contains or it is joined to a carbon which is joined to the same two carbons, right? And then over here, this unsaturated carbon is joined to two hydrogens. So that is why both of them will not be able to show geometrical isomerism or cis-trans isomerism. Okay? So we will say in both cases, one of the unsaturated carbons is joined to two same atoms or groups. Full stop. Next, draw the structure of a molecule that is positional isomer to C and D. So we want to draw another molecule that is a positional isomer to these two guys. All right. So the answer is very simple. How can we do that? This double bond can flip on this side, right? So we can have this, this, and this, right? Then this, and the double bond could be on this side now, like this. All right. So this could be our structure that is a positional isomer to them. Why is this called a positional isomer? Because the functional group is still on the first carbon, but the methyl branch is now on the second carbon instead of the third carbon in this one. All right. And how is it positional to D? Because in D, the methyl was in third. In over here, the methyl is on second. And in C, it is positional because in C part, the carbon-carbon double bond was on the second carbon. In this, the carbon-carbon double bond is on the first carbon. Next question. Give the structure formula of compound formed when D reacts with H2 in the presence of PT catalyst. D reacts with H2. All right. So D reacts with H2 in the presence of platinum as catalyst. It will produce an alkane with a methyl branch on the second carbon. So we will write CH3, CH, CH3 in bracket because that is the branch on the second carbon, then CH2, and then CH3. All right. Next, C can form an addition polymer. Draw the structure of one repeat unit of addition polymer. All right, so we want to draw the structure of one repeating unit of this addition polymer. So how will we form the one repeat unit? It is very simple. So first of all, this was C, right? This was C. Just duplicate the double bond. All right. So for a question like repeat unit, you do not want to do skeletal formulas, right? Skeletal structures, they are not the best for drawing repeat units of addition polymers. So the better way is to first of all convert it into its structural formula C double bond C. This guy has a CH3 on top and a CH3 on the bottom. This guy has a CH3 on top and a hydrogen at the bottom, right? Now, if we want to polymerize it, all we have to do is just simply duplicate it, all right, and remove the one double bond and show the double bond like this. We only had to show one repeat unit as it said, so we are doing one repeat unit, all right, and then just a bracket like that and a bracket like that, all right. This is how this structure should be drawn. This is the repeat unit, all right. Next, the mass spectrum of C shows a molecular ion peak at m upon E equals 70. This peak has a relative intensity of 48.7. The relative intensity of m plus 1 peak is 2.7. Show that this information is consistent with molecular formula of C. Beta, for this, we are given a formula, right, to calculate the number of carbons. Number of carbons, right? And what was that formula? It is the formula of abundance of m plus 1 peak divided by intensity of m peak multiplied by 100 upon 1.1. That is the formula, right? So let's use this formula. 2.7 divided by 48.7 multiplied by 100 upon 1.1. All right. This is always to calculate the number of carbons. If you know the intensities of m plus 1 peak and m peak, you can always use this formula. So it becomes 2.7 divided by 48.7 multiplied by 100 divided by 1.1 is equals to the 5.04. This is equals to 5.04, which is equals to 5. We can say therefore molecule should contain 5 carbons, which it does. First one. All right. Next question. C and D both react with HBr. C reacts with HBr to form E. Complete the diagram in figure 4.2 to show the mechanism of this reaction. Draw the structure of organic intermediate. Include charges, dipoles, lone pair electron, curly arrows, etc., as appropriate. All right. So we have C. They're reacting with HBr. We have to draw curly arrows and all that. Okay. So this is partial positive. This is partial negative. This arrow goes here. This attack goes, oh sorry, the double bond attacks here, all right, and we are left with like this, all right. And now the decision is ours. We can make this the carbocation or we can make this the carbocation. Which one would you make? You would obviously make this the carbocation as it is more stable, all right. So the hydrogen should be attached over here. This hydrogen should be attached over here, all right, and this will be the carbocation, and your Br with the lone pair is right here. It will provide over here to produce Br. Oh wow, they have actually shown us that carbocation must have been that. Okay, so that is completely fine. D reacts with HBr to produce F, a chiral bromoalkane. Draw the structure of F. We want to draw the structure of F, which is a chiral bromoalkane. So a chiral bromoalkane would mean कि first of all, what was D? D भूल गया हूँ मैं. So let's look at D. D was this. Okay. D was this. CH3, C, CH3, C double, not double bond over here. The double bond is over here between these two. C. Right. This will be CH2 and this will be H. So if HBr is to react, Br must join to this carbon because Br can only join to either this carbon or this carbon. If it joins to this carbon, it can't be chiral. So it will have to join to that carbon. So we will draw the structure of F and we have to draw it in skeletal structure form. That and the Br would have joined over here. All right. Next, Explain why the reaction of HBr with C and D produce different major products. Why do they produce different major products? Because in C there is a tertiary carbocation, but in D there is only a secondary carbocation. We have to write that down. We have to write according to Marco. I think Marco is Marco. 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 Of rule. Major product is the one with more stable carbocation. All right. In C, a tertiary carbocation can form on third carbon, while in D, only the secondary carbocation can form. Only a secondary carbocation can form. Full stop. Next question. C can be used to form H. All right, C can be used to form H. One possible synthesis of H is shown in figure 4.5. Different portions of C are used in reactions 1 and 3. Some of the products are then combined to produce H. Figure 4.5 does not show any of the inorganic products of the reaction. All right, this was the question I gave you guys in your mock exam as well. Um, Complete table 4.1 with the reagents and conditions required for each of the reactions shown in figure 4.5. Um, sorry, I don't think I gave it in the mock exam. I gave it in your organic chemistry test. So C reacting with E, the reagent is HBr. What happens when E forms J? So where is E and where is J? E, it forms J, but we don't even know J right now. But we do know that J, when it reacts with G, it produces this. All right. Acha ji. So now you are going to have to think about what J could be. All right. And how has that formed? For that, you need to understand that G was this and a ketone. All right. Now, this G, what must it be? How could a ketone form from an alkene? By hot concentrated KMnO4, right? Hot concentrated KMnO4 would produce a ketone, that is this part, and G would be the rest of this part, which would be C double bond O CH3 OH, right? So G is basically methanoic acid right here, that is G. The uh, carboxylic acid right here, the methanoic acid. So J is this much part, right? This part is the derivative of G, this part is the derivative of J. So J is basically alcohol, that is J, right? And how can you make an alcohol from halogenoalkane? You use aqueous sodium hydroxide. You use NaOH, aqueous. Next, C reacts to form G and ketone. So that was esterified KMnO4, hot concentrated one, hot concentrated acidified KMnO4, and last J and G, they are reacting to form H. All right, this is esterification, right? Because J was alcohol and this is carboxylic acid. This must be an ester. All right, so because ester is forming, all you need to do is you have to add the catalyst sulfuric acid, H2SO4. All right, you have to add sulfuric acid. All right, and with that, this past paper has been completed, alhamdulillah. with few minor issues. Do you guys have any questions?